All right, so a lot of what we're reviewing today is like SOHCAHTOA right triangle stuff, but the top of the worksheet does review degrees, radians, radians to degrees. This is a site that talks about this. I just was going to show you. Actually, it's not what I wanted to do first, though. Does anyone know the definition, kind of what a radian is? A radian is actually a radius. If you take and draw a circle and you talk about the radius, okay? If I take this length, let's see if I can get a cursor going better here. If I take this red length and I lay that exact, took a string that long and laid it across along the circumference, okay? The angle formed here, where this radius is the same as this distance, that's a radian. Okay, so if we do this, we take the radius. Anybody know the definition of or the formula for circumference of a circle? Nobody remembers? Anybody remember that one? 2 pi r? Does that sound familiar? Okay, so if this is a radius and this is a radius, all the way around the circle is 2 pi radiuses, right? Because that's the definition of circumference. That sound familiar? Okay, so how many degrees is it all the way around the circle? So 360 degrees is 2 pi times a radius. Now are we making a little bit of sense where we get this pi radians thing when we talk? If I divide both of those by 2, I get 180 degrees is pi radiuses or radians. Does that make it a little bit of sense now? So the conversion that you learned, do most of you have that one memorized? That on the unit circle halfway around is pi or 180 degrees. Okay, so if you know that, then you want to change degrees. Say you have 12 degrees and you want to change it to radians, you just use dimensional analysis. Does this sound familiar? 180 degrees, pi radians. There isn't really an abbreviation for radians. When there's no unit, it's radians. Then the degrees cancel out, and then you would do some reducing. And on your calculator, you can just type 12 divided by 180, math, enter, enter, and it'll reduce that. Anybody know what that would reduce to? 12 would go into 180. It's 1 over 15. Thanks. So you'd have pi, 1 pi over 15, or pi over 15 radians. All right, this is coming back to you a little bit, the dimensional analysis and the, if you just came out of Trig, it's all fresh. But if you had honors algebra 2 last year, you haven't talked about this stuff for quite a while, right? All right, so we have degrees. We want to get to radians. So we're going to put the degrees on the bottom and the radians on the top. And then if you have your calculator, you're welcome to just type 375 divided by 180, math, enter, enter to reduce that fraction. This is over 1, right? 180 times 2 would be 360. So I'm guessing like 13/12, but that's probably totally wrong. What is it? 25/12? Oh, it's over 1. Yes. Okay. Everybody good? No? Yes. Is that not what you got? Did you do math, enter, enter? Did you put a pi in? You can't type the pi in your calculator. Okay, you're just reducing the fractional part. So 375 divided by 180, math, enter, enter. Maybe I should write that up here in case anybody. 375 divided by 180, math, enter, enter. And then you still have the pi there, okay? Because it won't, pi, it's not going to put the decimal back into that form. All right, don't forget the negative on this one, guys, when you do it. So it's negative 135 times, again, this is degrees, so we need the 180 in degrees in the denominator, pi in the numerator. 3/4, is that right? Negative 3/4. Everybody good? You can write that as 3/4 pi, negative 3/4 pi, or negative 3 pi over 4. Either one is fine where you put the pi. What does it mean that it's negative? Do you remember that part? Yeah, this direction is positive, and this may be in the notes in a minute. This direction is negative, so it went 3/4 of the way around to the pi mark here in this direction. So it would be in this quadrant. All right, now we're going the other direction. So right now we have radians. So when we go to convert, we need the radians in the denominator and the degrees in the numerator so that the radians cancel. And its pi radians is 180 degrees. This all makes sense until you get a radian answer that doesn't have a pi in it. And I'll talk about that in a second. Let's finish this one first. Here, pi radians divides out. 180 divided by 3 is just 60 degrees. Everybody good? Any questions about that? What I'm talking about is if I told you I had 2.8 radians, would you know what you had to do to change that to degrees? If it didn't have a pi on it, you would still say, well, pi radians is equal to 180 degrees. And then you would just simply type 2.8 times 180 divided by pi, and you'd get like 160.4 degrees. But I'm just encouraging you to think about the dimensional analysis. Don't just think, well, because there was a pi on top, I need a pi on the bottom. Make sure you understand it. All right, so anybody do this one already? We have radians, so we need to get rid of radians down here. And 180 degrees, let's see, this would go in here 10 times. The pi would cancel. Is it negative 1030, anybody? Okay, how would you measure that? We're going to talk in a second about coterminal. This is coterminal with something, means it ends in the same spot with a number that we would recognize more readily. So this went all the way around 360, and then another 360, which would be how much? 720. So if you add 720 to that, what do you get? 310? Negative still? So it went all the way around it. I think it landed in the first quadrant here. Because if you add another 360 to that, so if you go negative 1030 plus 360 3 times, you get positive 50. So it would wind up in the first quadrant. 50 is called coterminal, meaning it ends in the same spot. All right. Duh. Okay, what does coterminal mean? Location, spot, place. I don't know. What do you want me to say here? Okay. So 0 and 360 are coterminal, right? Same spot on the unit circle. What else? Pi in radians and 180 in degrees. What about radians? 0 radians is the same place as 2 pi radians. just some examples. Does everybody get what I'm talking about? That if you drew it, so if I said this is 46 degrees, what's coterminal with that? Can you give me two answers, anybody? Remember how to do this? So if you took 46 plus 360, you'd... Okay, what is this? 406. Okay, and then if you did 46 minus 360, it's negative what? Thank you. Those are both coterminal with 46. Everybody good? You add a rotation, take off a rotation. All right, so what do you do if it's in radians? Instead of adding and subtracting 360, you have to add and subtract what? Yes. Okay. If it asks for all angles coterminal, then you have to have a way to tell it, I'm going to keep adding and subtracting 360 infinite number of times, or I'm going to keep adding or subtracting 2 pi an infinite number of times. So what we do is we write plus or minus 2 pi n, where n is any integer. Okay? And you really don't need plus or minus. The book will just put plus, and they might use k, 2 pi k, I don't remember. But to find all the angles that land in the same spot, we'll say as 4 pi over 3 or something. This is an example, okay? To find all the angles coterminal with 4 pi over 3, you would say I could add or subtract 2 pi an infinite number of times. We're not going to use all angles yet very often, okay? What would it be if it was in degrees? Instead of plus or minus 2 pi n, it would be plus or minus 360 n. All right. Enough about that. So quickly, how would we find a positive and negative angle coterminal with 36? Anybody? Add 360 and we'd get 396. Did I do that right? Subtract 360 and we'd get negative 324. Thank you. What if it's already negative? Well, we could add a 360 and get, is that negative 45? Okay, so that's coterminal. But what could we do to get a positive one then? Okay, but if you subtract a negative, it's going to still give you negative 45. So we need to do what? I need a positive number, guys. Add 360 again. Positive 315? No? I need a positive answer and a negative answer. You could have gotten your negative answer by subtracting another negative 360, but then you're at negative 705, 765, I don't know what. Anyway, do you get the idea that just by adding, we got a positive, we got a negative, and then we added again to get another positive. All right. So what do we do if they're, you can change these to degrees if you want, but that's so much, yes. This was the negative answer. Yeah, you just need, there are infinite answers, okay? So y'all could give me all kinds of nasty numbers, and I would have to take it if it is a added or subtracted multiple of 360. But because this one was still negative, I just counted it as my negative rather than having to go back and subtract one. Okay, that help a little bit? All right, guys, it is perfectly fine to change these to degrees as long as after you've added and subtracted your 360, you remember to change it back to radians. That's a whole lot of extra work. You have a calculator that will do this. If you want to add and subtract 2 pi, just don't put the pi in, okay? So do 5/3 pi plus, now, you can do 5 divided by 3 plus 2, 5 divided by 3 minus 2, and do a math enter. Right. I would really prefer you start thinking about your fraction rules because you're going to need them desperately in a couple days. How do you write 2 with a denominator of 3? So 6, you multiply 3 top and bottom, right? So now you have 6/3. All right, so if we add it, we get what? 11 pi over 3. If we subtract it, what's 5 minus 6? Yep. Now, do you want me to show you on the calculator real quick so you don't freak out when you have to remember your fraction rules? The next one is negative 22/9. Is that right, guys? Okay. If I wanted to add 2 and then do my math, enter, I'd get negative 4/9. Now, if I add another 2, I'd get 14/9. All right. What I would have done was I'm going to say I'm going to add or subtract 2 pi. Well, I need to have a denominator of 9, so I have negative 22 pi over 9 plus or minus 18 pi over 9. Well, if I add once, I still have negative 4. This is like the one we just did, Tara, where I added once and it's still negative. So I might as well just add again to get the next one. If I add another 18 pi over 9 to my negative 4, I now have 14 pi over 9. So I got my negative and positive without ever having to actually subtract. Questions? I know some of you change them back to degrees, add and subtract 360, and then change them back to radians, but that's a lot of work. All right, SOHCAHTOA. You know how when you're trying to fall asleep and you're thinking about going back to school, you think about all the things that are going to happen this week. And I was thinking, how can I remind them about SOHCAHTOA that would be a new and fun way? Yeah, I didn't come up with anything very exciting. I didn't even... Do some of you use SOHCAHTOA and some of you use Oscar had a handful of apples? Anybody use either one of those or remember those? Some of you don't remember these at all. Okay. What we're trying to remember is the 3 right triangle trig functions. Okay. The sine of an angle, and the whole word is spelled like this, but we abbreviate it SIN. Of an angle, I'm going to use theta, is defined as the length of the opposite leg to the hypotenuse. That's what that stands for. But we learned it in geometry maybe as just so. Now you got to say this with a short A. You got to say ka, so that you remember that it goes with the A, which is the adjacent leg, and the whole word is spelled cosine. We abbreviate it COS, and we use adjacent leg over hypotenuse, it's the A. And then TOA is tangent, which is abbreviated tan, and it's O over A, so it's opposite leg over adjacent leg. Does anybody know which one of those can be more than one? Let's talk about a right triangle. When we have an angle, where's the longest side in this triangle? Always the hypotenuse, which is the one across, from the 90, right? So if this is the longest side, can this ever be more than one? A leg has to be shorter than a hypotenuse, right? So that's got to be less than 1. This has got to be less than 1. The 2 legs, though, opposite over adjacent, or if I was talking about this angle, opposite over adjacent, if it was this one, it could be longer, more than 1, right? The tangent can be more than 1. All right, so real quick, let's see if we remember any of this. Find the measure of the angle indicated. So we're looking for this angle at A where theta is. From there, what are these sides called? If I'm standing here at A, this is how I teach it in geometry, okay? Put in my smiley little self here. This is the hypotenuse, right? But what's this one called? Because it's right next to me, adjacent. A and H was in which one? Cosine, okay? Whoop, yes. So it's cosine of theta equals adjacent over hypotenuse. And then what do we do to get an answer for the angle? Yeah, we're looking to undo this ratio and find the angle. So we do second cosine 2 over 3.6. This should be coming back to you from geometry and maybe even 8th grade. But this would be an important time to discuss what mode we want these answers in. Yes, because we're talking about a triangle that we're measuring less than 90, we're going to just use degrees. So make sure your calculator is in degree mode. The rest of this stuff doesn't matter. And it never matters whether you're in radiant degrees, either one, unless you're touching sine, cosine, or tangent keys on your calculator. Then it matters. And we're going to do that, so we want to be in degrees. Not always, but for this question. All right? So I do inverse cosine. Can anybody remind me the numbers? 2 over 3.6? Thanks. As I said it, I see it at the bottom here. I got 56.3 if we round to the nearest 10th. Everybody okay? So tell me real quick how to do this one over here. This time I'm standing out here at A. Where's the hypotenuse? Hypotenuse is across from here. Do I need anything with the hypotenuse? No. So this is opposite. This is adjacent or next to. If anybody doesn't feel comfortable that they clearly know those opposite, adjacent, tangent, please let me know so that we can clear that up real quick. Okay. Opposite of here is the 9. Adjacent is the 3.7. What uses O and A? TOA or tangent equals opposite over adjacent. Now this time there is a bigger number on top, so we get this value would come out more than 1, but we want the angle anyway, so we're going to undo the tangent and give me the angle. Somebody get an answer? Everybody agree? Anybody else get that? Okay. Good job. All right, same thing, but now we're talking about finding sides. Same ratios, though. If you need to write it at the top, it's SOHCAHTOA. Remember when I said a minute ago, Oscar had a handful of apples? What that is if you have your calculator out in front of you, okay, it always goes left to right, sine, cosine, tangent. Do you see that on your calculator? So some teachers teach Oscar had, that would be OH, a handful, AH, of apples. So as they go across your calculator, the first one is opposite over hypotenuse, then adjacent over hypotenuse, then opposite over adjacent. That's just confusing to me, but if you learned it that way. All right, where do I put my smiley face on 14 real fast? What's the angle I'm working from? It's always the acute angle they gave you or that they're looking for, unless you wanted to do 90 and 64 from 180 and find this guy over here, but that's too much work for me. So I have opposite and hypotenuse, so I do the sine of 64 equals 25.6 over x. Now, how do we solve this? I always put this over 1 and just cross multiply and divide. Does that make sense? So I do 25.6 times 1, which is 25.6, And then I have the sine of x times 64. So how am I going to solve that? I never even write that stuff down. I just divide. But this is what you need to be typing in your calculator. 25.6 divided by the sine of 64. Anybody else get 28.5? How do I know if that's reasonable or not? You should always ask yourself that question. Carol, were you going to say something? Yeah, it's longer than this side, isn't it? Is that a reasonable answer then? Okay, it's the hypotenuse, so it has to be the longest in the triangle. So it is a reasonable answer. All right, real quick, which function are we using over here? Opposite, adjacent, smiley face. That would be tangent of 40 degrees equals opposite over adjacent. So again, we get 3.6 when we cross multiply this way, and we're going to end up dividing it by the tangent of 40. Please tell me if I do one of these wrong because I'm hurrying. I got 4.3. Is it reasonable? Well, yes. Anybody know whether it had to be more or less than 3.6? Do you remember this geometry fact? What do the angles in a triangle add up to? 180. So this one down here is 50. If this is a 40 and it's across from a 3.6 and this is a 50, then one across from it has to be bigger than 3.6. Do you remember that? Smallest angle across from smallest side. Okay. Just that will help, especially on the SAT. Think about that. If you can eliminate some of the answers because you know ahead of time, right? Which one is going to make sense? All right. We know this angle, so we have adjacent and hypotenuse. So that means I need what? Cosine of 60 equals x over 17. So as long as I want a decimal, I can just do 17 times the cosine of 60. This is an interesting moment because I think the next section, or somewhere on here, is special right triangles. 60 is one of those 30, 60, 90, and 45, 45, 90 you're going to have to memorize, okay? And the rule is, just watch up here for a moment of gloriousness. Do you remember if it was equilateral, they were all the same? Okay, so instead of calling these all x, I'm going to call these all 2x, and I'll show you why in a second. Because what happens when I split this? Now I can call these x and x. Okay, and then I just split this so it's 30. If I do Pythagorean theorem, what's 2x squared? 2x times 2x is 4x. This one squared is just 1x, right? I'm looking for a leg, so I subtract. What's 4x minus 1x? Okay, let me write it out. Hypotenuse squared equals leg squared plus leg squared. The hypotenuse is 2x. This little leg down here is 1x. And I'm looking for this guy. Okay, this became 4x squared. This is an x squared. If I subtract 1x squared, I get what? 3x squared. How do I get that leg by itself? Square root. So I end up with square root of 3x. Do you remember this pattern? 2, 1, and square root of 3? Yes. It is the square root of, it's the square root of 3x squared. So it's the square root of 3, but the x is not in the radical. I didn't write it very well. We usually write x square root of 3. All right, moving over here. From this guy, we have opposite and hypotenuse. So we're using what? Sine 47. This is not one you should have memorized. And it's 19 over x. So am I multiplying or dividing these numbers? The 19 and the sine of 47. Is it 19 times the sine of 47 or divided by? Okay, because the x is in the denominator, you get 19, and then you have to divide by the sine of 47. Somebody get an answer? So 26.0 if we round to, okay. All right. Now, some of you, it's been a really long time since you talked about these terms. The reciprocal functions, okay? Didn't do those in geometry, right? But you did them in Algebra 2 or you did them in Trig. The reciprocal of sine is when you flip it over and have opposite over, or hypotenuse over opposite. And it's called cosecant. Now, we'll talk about this later, but sine and cosine sound like they go together, right? But sine and cosecant don't sound like they go together. Okay, this is how I remember it. Sine, cosine, or cosecant, cosecant, secant. When you flip it over, it changes, right? From C to S and S to C. Then you got to remember tangent and cotangent actually go together. This is on the back of your unit circle sheet, I think, at the top. It's really a gift because you should have this memorized, but is it on the back, the definitions of the reciprocals? It says like, yes, doesn't it say like sine equal, or 1 over sine equals cosecant? Okay. Any questions? Hope you're remembering that stuff. Did you get a sorry, Moira, did you need more time? Anybody else trying to write these down? We good? They are on the back, like I said, of your reference sheet, which you will get to use on everything except the unit circle quiz. Okay. The value of the trig function indicated. Okay. Cotangent is the reciprocal of which one? Tangent. Okay. Tangent was TOA, or opposite over adjacent. So this one is adjacent over opposite. The theta is down here. Uh-oh. What's going on? This is opposite. This is hypotenuse. This is adjacent. Yep. That's exactly what we have to do. Yep. That's exactly what we have to do here. We have to do Pythagorean theorem. Now, the two legs are 6 and are unknown. I'll call x. So we'd have 6 squared plus x squared equals the hypotenuse squared. How many of you have memorized that 3, 4, 5 makes a right triangle? You have legs of 3 and 4, the hypotenuse is 5. Do most of you have that one memorized? Well, guess what? You can do multiples of that. So if I double all those, I have 6, 8, 10. So this would be 100. This would be 36. 60, yes. If I subtract, I get 64. I square root, I get plus or minus 8. But can we have a negative 8 on a triangle? No. So this side is 8. So adjacent over opposite is what? 8 over 6, or 4/3. This is where everybody does wrong. Does it ask you to find the angle here? It says find the value of the trig function. So it wants 4/3. Okay? Yes. No, because this triangle is not on the coordinate plane. Okay, so it can only have positive. Great question, though. We'll get there. All right. Cosecant is the flip of which one? Sine. Sine is opposite over hypotenuse, so we're looking for hypotenuse over opposite. Well, guess what? We don't know the opposite, right? Now, how does Pythagorean theorem go on this question? 25 is the hypotenuse, right? So it's 24 squared plus some leg we don't know squared equals 25 squared. This is actually a Pythagorean triple too, isn't it? What's 25 squared minus 24 squared gives you 49. So when we square it, we get 7. So this leg over here is 7. So then we were supposed to do hypotenuse over opposite, which would be 25 over 7. Too fast? We good? All right, tangent. Okay, how are we going to square this mess? So to find this, which is adjacent, tangent is opposite over adjacent, so we need adjacent here. To find that adjacent side, we have x squared plus 18 squared equals 9 square roots of 5 squared, which you can do on your calculator. But in my brain, I just square the 9, which is what? 81. I square the square root of 5, and I just get plain old 5. So 81 times 5, or you can type the whole thing in and square it. Just be really careful. Was 405. And this was 324. So if I subtract, so I square root and I get 9. So what is the answer to the question here? Opposite over adjacent is 18 over 9, or just 2. All right. I call these draw questions. You maybe don't need to draw. Actually, what's cosine and secant? What's the relationship? They're reciprocals, right? So you could just say this is 5 over 13. Sometimes you have to draw them out. Let's see if we have to do the next one. 23 tangent to cosecant. Yeah, that's not a reciprocal, right? So this is what I do. I don't know if this makes sense to you. I just draw a little triangle and I do, well, tangent is opposite over adjacent. So I have 8 and 15. Then this one, cosecant, is what? The flip of sine. So it's hypotenuse over opposite. So I need the hypotenuse. Anybody know this one in their head? This is another Pythagorean triple. 64 and 225 is 289. Anybody know square root of 289? 17. So what is hypotenuse over opposite? 17 over 8. Okay. Cotangent. How am I going to label this one? Cotangent. Anybody know what those are? Tangent is opposite over adjacent. So this is adjacent, opposite. Okay, I'm going fast, but if I square those, what do I get? 25 and 11 is 36. Square root of 36 is 6. Secant is hypotenuse over adjacent. So I get 6 over square root of 11, or 6 square roots of 11 over 11. How close did we get to finishing that worksheet? Oh, that was the last one? Yay! Okay, so your homework is to work on 3AB, 4A, and page 227. Guys, it's all listed, right, on the blue sheet. The first assignment on the blue sheet. Everybody have everything? Yeah. Okay. Yes. Wherever you need to. Yep. Yeah, you're fine. Good morning. Yes, I cry every day. It was good.